Hey guys, it's Miss Fendley. So before we jump into today's notes, I want to review something from yesterday and then cover one more thing to kind of go with that idea. So yesterday and Friday, we were looking at the sum of interior angles. So if I take a shape, any shape, let's see what I can draw. We'll go with a hexagon since that's what came out. And I want to know what each of these angles adds up to. If I add them all together, what number would I get? So if I take these angles, or these figures, and divide it into triangles, well, each triangle measures 180 degrees. So the number of triangles that a figure can be divided into times 180 tells me the angle or the number that all 6 of these angles will be adding up to. Oops, go away. Okay, so find the sum of the interior angles, or the angles on the inside. We said n minus 2 times 180. N minus 2 being the number of triangles that it could be divided into, times 180 to get the total number of degrees. Okay, in a regular polygon, remember yesterday we said that in a regular polygon, all the sides are the same and all the angles are the same. Okay, so this is not a regular polygon. Draw one. Wow, that is really not. But let's pretend that it is. Do your best. Draw, if you can, draw a regular polygon. But in a regular polygon, all of the angles are the same. So if I wanted to know what do each of those angles add up to, well, if they're all the same, I'm going to take the sum, that n minus 2 times 180, whatever number that is, and then I just divide it by the number of corners because all the corners are the same. So if I said to find the measure of each interior angle or one of the interior angles of a regular polygon, I'm just going to say n minus 2 times 180 divided by n. So I'm going to put each interior, and that's the angle sign just because I'm running out of space there. So n minus 2 times 180 is the sum, what all of the angles will add up to. And if it's a regular polygon, just take n minus 2 times 180 and divide it by the number of sides n, and that will tell me what each angle measures. Okay, so yesterday, Friday, we looked at interior angles being the angles on the inside of our convex polygons. Today, let's look at exterior angles. Okay, exterior angles or an exterior angle is formed by extending a side in one direction. Okay, so if you look at the picture on the left, we can extend sides in both directions, but when you do that, you end up creating a whole bunch of angles there. You've got your 4 angles, your 2 pairs of vertical angles. So, but only one of those where it's formed by a side of the figure and extending one of the sides. Right, so sandwiched in between an actual side of the shape and one of the extended legs. Okay, I think the second picture does a better job of illustrating that, where when you extend it in one direction, the angle in between that extended side and the shape, or the side of the shape, is your exterior angle. All right. So this polygon exterior angles theorem So to find the sum of the interior angles, you have to do fancy math. You have to say n minus 2 times 180, divided into triangles. Exterior angles, super easy. The sum of the measures of the exterior angles of a convex polygon with one angle at each vertex is 360. Always and forever. Okay? So if I take angle 1, angle 2, angle 3, angle 4, angle 5, and added them together, it's going to be 360 degrees. That's because if I took this shape and cut out those angles and put them together, they would actually make a circle. So it'd be 360 degrees. So adding all of the angles up, and that's not just true for this pentagon, that's true for every shape, for hexagons, dodecagons, nonagons. When you take the sum of the exterior angles is 360. So like you may genuinely have a problem on your test that says find the sum of the exterior angles of a convex heptagon. Your answer, 360. Like seriously, it's not a trick, just 360. So on this first example, it says to find the value of x in the diagram. Okay? We have four exterior angles. And what is the sum of exterior angles? We don't even care what type of shape this is. The sum of the exterior angles, 360. Very good. So I'm going to say 2x plus x plus 67 plus 89 equals 360. They just all add up together to equal 360. I combine my like terms. So 3x plus 156 equals 360. Start solving. Subtract 156 from both sides. So 10, 5, 2, 0, 4, so 3x equals, both sides by 3. X equals 68. Okay. X equals 68. All right. And since our instructions just said to find the value of x, doesn't say to find the measure of the angle or anything, we don't have to plug it in. So we're done. So literally when it gives you these exterior angles, you just add them all up and they equal 360 degrees. All right, so I'm going to give you guys like 2 minutes to do the U-try. Remember, the sum of the exterior angles is 360 degrees. All right, hey Siri, set a timer for 2 minutes.
Okay, 2 minutes and counting.
minutes is a really long time sometimes. Ooh, there we go. Okay. So, hopefully you guys set this up. You said add all these sides together. I'm going to say 2x. Oops. Let me pick a new color. Let's do purple. Purple's good. 2x plus 3x plus 44 plus 85 plus 71 equals 360 degrees. Yeah. And all right, so 2x plus 3x is 5x. And let's see, 44 plus 85 plus 71 is 200. Okay, so 5x plus 200 equals 360. Subtract 200 from both sides. So 5x equals 160. Divide both sides by 5. So x equals 32. And again, the instructions don't ask us to find the angle measure, just to find the value of x. So you're done. Well done. All right. Flip on over. I'll leave it there for just a second. Make sure everybody's got that all copied down. I'll leave it alone. Okie dokie, friends. All right. Let's flip on over and look at this example too. All right, so it says finding angle measures in regular polygons. So we have a trampoline here. It says the trampoline is shaped like a regular dodecahedron. Dodecahedron means that it has 12 sides. So dodeca, 2 and 10. 2 and 10 is 12. Regular means all the angles are the same. It asks us to find the measure of each interior angle and the measure of each exterior angle. So I am looking for, let's see, will this show up? Yeah, it does. Okay. The measure first of each of these angles. And then I'm going to look for the measure of each of the exterior angles. So for the interior angles, before I can find the measure of each interior angles, I have to know what they add up to all together. So to find the sum of interior angles, let me put that. Sum of interior is, just write it out, n minus 2 times 180. Well, n is 12 because it's a dodecahedron. So 12 minus 2 times 180. 12 minus 2 is 10. 10 times 180 is 1800. So those angles all together will end up being 1800 degrees. Okay. And if I want to know what each of them measures, I'm going to take that interior sum, that 1800, divided by the 12 corners. And each of those angles measures 150 degrees. Okay? Each angle measures 150 degrees. Yeah? And you could do that all as one formula if you wanted to. You could do that as, I'm going to put a squiggle here, as 12 minus 2 times 180 divided by 12, which is order of operations is going to be the same thing. You're going to do the stuff on top and the stuff in parentheses first. So 12 minus 2 is 10. 10 times 180, and then 1800 divided by 12. So same thing. Each of those angles measures 150 degrees. Okay? All the way around. On part B, it's asking us to find this measure of each exterior angle. So if I have this interior angle and I extend them, let's see, one didn't extend as well. I keep extending them in one direction. I'm looking for this angle measurement, okay? So I have two options here, okay? First option is I know that the sum of the exterior angles is 360 degrees. No math involved, just all of them together is going to be 360 degrees. And since this is a regular dodecagon, which means all the corners are the same, then each exterior angle would just be 360 divided by the number of corners, okay? So in this case, it would be 360 divided by 12. So I'm going to double check my work on that, make sure I'm not having a brain fart. Nope, okay. So 360 divided by 12 is 30 degrees. Okay. So each of these angles is 30 degrees. The other way to think of it is, notice this is a straight line. And what do we know about straight lines? Right? They measure 180 degrees. So if I have this straight line, oops, that's not a straight line, hang on. Okay, so that this is 150 degrees. Well, that doesn't show up super well. Yeah. If this is 150 degrees right here, well, 180 minus 150 is 30. So it makes sense that that's a 30-degree angle. So when it tells you to find the measure of each exterior angle, you've got two options: 360 divided by the number of sides, or 180 minus the interior angle, because it's a linear pair. So that is it for the 1.1 notes. We were finishing those up from yesterday. Let's see. We'll see something in a minute. All right. So formula summary, interior angle sum. So anytime you see a sentence where where you see the word sum and the word interior in the same sentence, n minus 2 times 180. So seriously, it may say, what is the sum of the interior angles? What is the interior angle sum? But anytime you see the words interior and sum in the same sentence, n minus 2 times 180. If you see each interior angle or an interior angle, so you're just looking for one, it's n minus 2 times 180 divided by n, so divided by the number of sides. Again, if you see exterior angle sum, so what is the sum of the exterior angles of a quadrilateral or whatever? 360. No math involved, 100% of the time it's 360. And then each exterior angle, or find an exterior angle of a regular polygon, 360 divided by n. Okay, so that is just a very short summary of those notes. Okay. Doesn't feel like it's been very long. Let me see. Yeah, I think we're going to go ahead and start the section 7.2 notes. So I'm going to stop this video, take a moment to breathe. If you need to stand, touch your toes, touch your neighbor's toes while we switch over the videos. But take a break, have a good moment.